So these are the notes that you guys copied in class straight from the board. If you are multiplying two terms with the same base, add the exponents and keep the base. So if you have x squared times x to the third, it's the same base, just add the exponents, keep the base. Now the reason why this is true is because if you think about it, x squared times x to the third, what is that really? X squared is x times x, and x to the third is x times x times x. So you really do have the multiplication in between them. So you really have a total of 1, 2, 3, 4, 5 x's, so that's why it's x to the fifth. Mathematicians always realize the truth and then make shortcuts. So instead of, this is called expanding, instead of expanding, they just said, hey, if I add the 2 and the 3 together, I'll get my answer x to the fifth. Does that make sense? Okay, now, obviously, we're going to have more challenging questions than x to the second times x to the third, which is x to the fifth. And that rule could be applied even if you have numbers. For example, let's say you had 2x to the third times 3x to the, give me something. Fourth. Okay. If I had this, then I would be able to multiply. Now, there's commutative property that exists in multiplication. In other words, even the 2x to the third is really 2 times x to the third. Even the 3x to the fourth is 3 times x to the fourth. So technically, I could rearrange this and make it 2 times 3 times x to the third times x to the fourth. Right? I could do that. And then I would get 6x to the seventh as my final answer. Now, after you do this a couple of times, you probably won't show your work and rearrange it. You'll just do it in your head. 2 times 3 is 6. X to the third times x to the fourth is x to the seventh. So let me erase this. So if we understand that first one, let me just scratch that out, can't erase it. If we understand that first rule, let's move on to rule 2. Rule 2, Mario. It says if you have a power to a power, multiply the exponents. Power to a power, multiply the exponents. Once again, there's an explanation for that. It's not that somebody just made it up and said, oh, when you have power to power, multiply. No, x to the second to the third. If you go x to the second to the third, what that really means is x squared times itself 3 times. X squared times x squared times x squared, which is really x times x and x times x and x times x. And there's multiplication between those x's and multiplication between those pair of x's, which means that you have a total of x to the sixth. It's a total of 6 x's. So instead of actually showing all this work, this is called expanding. Instead of showing all that work, we just jump straight to the answer. We learn the rule that says when you have a power to a power, you multiply. Mario, what do you think of that? So it's as simple as that. A power to a power, you multiply. Okay? And this last one right here, if you have parentheses with an exponent on the outside and a monomial on the inside. Now, I underline monomial because it's important that we understand what a monomial is. It's a single term. Now, what do I mean by single term? You could have multiple variables in it. It could be something like 3x to the second, y to the fifth. It could be like x to the third, y to the fourth, z to the fifth. But it cannot be something that's separated with a plus or a minus. So if you have like x plus 2, that's no longer a monomial, that's a binomial. Or x squared plus 2x minus 3, that's a trinomial. A monomial is simply one term inside your parentheses, no addition or subtraction separating anything, all multiplication, okay? So let's take a look at, let's finish this. It says, if you have parentheses with an exponent on the outside and a monomial on the inside, then distribute the outside exponent to all the inside exponents. Okay, so number 1 right here, the example that we show, it does have a monomial in here. Notice there is no plus sign like 2x to the third plus yz to the fifth. That's not there. There's no plus sign there. It's all together. All together. That's a monomial. Does that make sense? Okay. Now, the rule says that when you have a monomial on the inside of the parentheses and a power on the outside, that power gets distributed, but it gets distributed to the other powers inside, to the other exponents inside. So don't think of this 2 with this over here, it's not 2 times 2. It's really not 2 times 2. Oh, it's 4 though. No, it's not 2 times 2. It's really the power of 2 to the power of 1. And a power to a power you multiply. So 2 times 1 is 2. So you really have 2 squared, and that's why we get a 4 right here. 2 squared is 4. Power of 2 to the power of 3, that's really power to a power you multiply. 2 times 3, that's 6 on the x. 2 times, there's an invisible 1 right here on the y. There's an invisible 1 on the y. So 2 times 1 is y squared. 2 times 5 is z to the 10th. Does that make sense? Yes. So this is the third and the most challenging one, where you distribute the outside exponent to each exponent on the inside of the parentheses. Now keep in mind, if you had a plus sign right here, you couldn't do it. Okay? So you can't really have, it has to be all together with multiplication. In other words, right here, between the 2 and the x, there's multiplication. Between the x to the third and the y, there's multiplication. Multiplication. Then you could distribute, and remember, you're not distributing it to the number, you're distributing it to each of the exponents, and some of those exponents are invisible, right? So we had a good question. If you had a plus sign in the middle, why couldn't you distribute the exponent? Well, let me just zoom in on this part of the board right here, and let me show you this. If I had, let's say instead of 2x, if I had 2 plus x squared, you cannot distribute the 2. Why? Because this is not a monomial. This is actually 2 terms. It's a binomial. So technically, what you would have to do to be able to do this problem, you would have to write it twice. 2 plus x times 2, well, that's ugly, times 2 plus x. And you would have to distribute and say 2 times 2 is 4, 2 times x is 2x, x times 2 is another 2x, and x times x would be positive x squared. Does that make sense? So it would not be 2 squared plus x squared, because that would simply be the answer x squared plus 4, and down here we're not going to get the answer x squared plus 4. It's different. So if there's a plus or a minus, you cannot distribute. Now, on today's homework and on tomorrow's quiz, you're not going to have any of them that have a plus or a minus. They're all going to be monomials. You are going to be able to distribute to the inside of the parentheses. Does that make sense? Okay. It's taking me too long to erase that. Yeah, there's going to be a quiz tomorrow.
Yeah,
now,
what's going to be in it? Like the graphs and everything?
These 3 rules that we're learning right now.
Only that.
So let's check out this second example of this third rule. Guys, in this one, there is no addition or subtraction separating anything, right? So the rule applies also. This is one term. It's an ugly fraction with many variables in it, but it's still one term. It is a monomial. So I'm going to take that outside exponent of 3 and distribute it to each of the inside exponents. Okay? Now, some students make the common mistake and they think, oh, this is wrong. This 27 is wrong. It's supposed to be a 9. But you see, you guys aren't listening to the rule. The rule says distribute the outside exponent to each of the inside exponents. So what exponent is on x? There's a 2, and 3 times 2 is 6. What exponent is on the y? There's an invisible 1, so 3 times 1 is 3. What exponent is on the 3? There's a 1 right there. 3 times 1 is 3. So you really have 3 to the third right there, and 3 to the third is really 3 times 3 times 3, which is a 27 that you see right there. Not 9. You guys got it? And of course, you keep distributing 3 to the 4th, or not 3 to the 4th, but the power to a power. 3 times 4 is z to the 12th. And that's how we get that one. So we've gone over all 3 rules. Now let's practice rule 1. So what do you guys say about number 1? What's our answer going to be on number 1? 6x to the 5th power. Piece of cake, right? 5th power. Because rule 1 says that if you're multiplying with the same base, you end up adding the exponents. So the power of 3 and the power of 2 get added. Now, ladies and gentlemen, what you could do to make it clear for you guys, but like after you do this a couple of times, you're not going to be rearranging anymore. You're just going to do it in your head the way we did it right now, and we got the answer 6x to the 5th. But what you could do is, instead of 2 times x to the third times 3 times x squared, you could write the 2 times 3 together. And then you could write the x to the third times x to the second together. And then you could clearly see your answer 6, which is right there 6. And then x to the third times x to the second is x to the fifth. Now let's take a look at the second example from Rule 1. The second example, you have 3x squared y times 4x to the third y to the fourth z. So again, you can rearrange everything. You could say, okay, I really have 3 times x squared times y times 4 times x to the third times y to the fourth times z. And you could move things around, and you could put the coefficients first. You could say 3 times 4 first, which you know is going to be 12. And then you could put the x to the second times x to the third right next to each other, and that'll be x to the what? X to the 5, x to the fifth power. And and then the next one, y to the first power times y to the fourth. Let me actually write that. Y to the first power times y to the fourth power. What do we get? Y to the 5 also. And then last but not least, we have a z at the very end. So let me put down a times z at the very end. And that's my final answer right there, guys, for number 2. 12x to the fifth, y to the fifth, z. That is all on rule number 1. I hope you guys understand that. Let's move on to rule number 2. When you have a power to a power, you multiply. So we have 2 examples right here. I hope you guys are keeping up. So rule 2 says a power to a power, you multiply. So what's this answer going to be? On number 1? X to the 6th. Okay, piece of cake. How about number 2? X to the 24th. Why? Because 2 times 3 is 6. 6 times 4 is 24. There's a final answer. Done. And let's move on to the third rule. Let's take a look at number 1 and number 2 right here. So what's the answer to number 1? Don't say 6x to the third, because that's going to be wrong. It's not 6x to the third.
8x to the third.
8x to the third, that's right. Now keep in mind, the rule says when you have parentheses, the outside exponent gets distributed to the inside exponents. There's an invisible 1 right there and an invisible 1 right there. So power to a power, you multiply. So you really have 2 to the third, x to the third. And 2 to the third, you could actually do that. You have to do it. What is 2 times 2 times 2? That's not 6. That's 8x to the third. Number 2, let's take that outside exponent 2 and distribute it to each and every exponent on the inside. There's an invisible exponent of 1 right there and an invisible exponent of 1 on the y also. So take that 2, put it there on the 2, on the 1, and on the 3. Now, power to a power, you do multiply, so you're actually multiplying through. So you're going to get your answer, which is 3 squared x to the fourth, y to the second, z to the sixth. And the only other thing you could do is write it as a 9, x to the fourth, y to the second, z to the sixth. Because 3 squared is 9. And now for the last one, the most entertaining one. You have a fraction, and you want to distribute the outside exponent to every term on the inside exponents. Or on each exponent on the inside. So 5 is going to get distributed to the 2 and to the invisible 1 on the y. The 5 is going to get distributed to the invisible 1 on the 2 and the 5 on the z. So our final answer is going to be what? X to the 10th, y to the 5 over 2 to the 5th, and z to the 25. The only other thing you could do is change the 2 to the 5th to what's 2 times 2, 4 times 2, 8 times 2, 16 times 2, 32. So you could technically change this to a 32z to the 25th. So you could rewrite that denominator as 32z to the 25th. That's really ugly. Our final answer is x to the 10th, y to the 5th, over 32z to the 25th.